Hello, astronomy. Let's go ahead and get started on Workbook 4. We're going to be taking a look at the structure of the solar system and the parts of the solar system. So we're going to go ahead and we're going to get started on Chapter 7, the structure of the solar system. So I'm going to turn my page sideways, and if you're working with paper, that might be a good idea. Now, people who are on tablets, may want to zoom in quite a bit. That's good enough. But working sideways is going to give us a little bit more length for space for our diagrams. So we're going to start off with just getting some of the major players in the solar system and understanding the order of the planets and that sort of a thing. So we're going to start off. Now I'm going to open up with this is not to scale. That is a big, important concept. So, for example, the orbit of Neptune is about 10 times farther out than the orbit of Mars. When we're looking at things like the Oort cloud, those are massive, massive distances away from the edge of this from the orbit of Neptune. So when I'm sketching this out, keep in mind that this is really just about order and a general pattern and not what the actual distances between the planets are. So we're going to start over here. The center of our solar system is the sun. We all knew that before coming in. And then we have our first four planets. I'm going to turn this way to make it a little bit easier. So this is Mercury, Venus, Earth, and then the fourth planet is Mars. And these four planets together have something in common. These are all our terrestrial planets. And terrestrial comes from teres, which means Earth-like. In other words, these are rocky planets. Okay. Now, next out from that is this zone between Mars and Jupiter, which is known as the asteroid belt. So an important point here, these are rocky or metallic objects. And it includes the dwarf planet Ceres. So Ceres is a dwarf planet. We'll get a little bit into what a dwarf planet is as part of this class, but this is these rocky and metallic objects, and that includes dwarf planets. And these are objects that are too small to do what's called clear their own path. In other words, use the gravitational pull to make sure their path of their orbit around the sun is clear of other objects. Then as we move out, we start getting the big ones. So next one out is Jupiter, then Saturn, then you can say Uranus or Uranus, depending on depending on your maturity level. I like saying Uranus. And then we have Neptune. Now, there are two ways to cluster these planets. One is that we can cluster them in the types of giants they are, because these are much, much more massive than the terrestrial planets. We refer to them as giants. These two, Jupiter and Saturn, are our gas giants because they are gaseous. And then over here, we have our ice giants. So if I ask you, is Uranus gassy? You can say, no, it's icy. See what I did there? I have the maturity level way below my age level. Now, these planets together are known as the Jovian planets. And the Jovian planets, Jovian, just like Teres refers to Earth, like terraform means to make Earth-like. Jovian refers to Jupiter. And these tend to be icy or gassy. Now, beyond that, the next layer outside of the solar system, and we're going to talk about why the structure is like that, is another belt of small objects known as, this is the Kuiper belt. That's a very Danish name, Kuiper. And these contain icy objects like comets that are made of frozen ice, or in some cases gases, or what would be gases on Earth but have frozen. So for example, frozen carbon dioxide, frozen methane. And it includes several dwarf planets. Such as Pluto, Eris, Makemake, and Haumea. Okay, so we have, there are 8 planets. So far we have 8 planets and 5 dwarf planets. Now the last part here, outside the Kuiper belt, we have what's called the Oort cloud. So the Kuiper belt includes close, what we call short period comets. Period is the time it takes for the object to go around the sun. So we call it short period. So in other words, this takes a shorter amount of time to go to the sun, 100 years, 80 years. One example is Halley's Comet is here, and that is 76 years to go around the sun. Whereas the Oort cloud include distant, long period comets. And comets over there. Okay? And there may very well be other dwarf planets lurking out there in the Oort cloud, or even in the Kuiper belt, or even in the asteroid belt. We're still learning. We're still looking at these distant objects and getting to understand them. So, to understand the makeup of our solar system, for the record, there are 8 planets, and there are 5 dwarf planets. So if you're one of those people, and I meet them every semester in astronomy, they're like, oh no, poor Pluto isn't a planet. Don't feel bad for Pluto. Pluto's got his own family of dwarf planets. And they're a very happy little family, mostly living out there in the Kuiper belt.